Hello everyone. Today we are going to see how to calculate the residuals in multiple regression model. This particular video I just wanted to tell, actually one of my subscriber asked me to put a video on how to calculate error in multiple regression model. So just to fulfill his views, and because we want to support the subscriber, we just wanted to create this video of calculation of residuals in multiple regression model. We'll quickly move on to the video how to calculate this. See, first of all, I just wanted to tell you, see, there are two things here you have to note. The first one is the population regression function. So how it has been given, just we have to see here, population regression function. So it is denoted by yi and beta naught and bi sigma xi plus epsilon I. This we have given that video just like this. Y is equal to beta naught plus beta 1 into x1 plus beta 2 into x2 plus beta 3 into x3, etc., up to beta n xn. I can have like this. Plus, there is a error function here. You have to note down here. Okay. Now, this particular error, this is an error. Okay, random error. We'll call this as random error. So it is not observed. Okay. So whenever there is a population, this particular error is not observed. So when we go for first of all, I just wanted to tell you what is this y, what is this beta naught. Okay, so now these xi's are independent variables, yi's are the dependent variables, and beta naught is nothing but the constant beta I. Okay, beta I, we are going to calculate the regression coefficients. This epsilon I is a random error term. Okay, this random error term, when it is coming in the population, it is not observed. Okay, so now we are not going to calculate this anyway. So when we go for the sample, see this particular how to calculate this regression coefficients, we have done it in a video. The link for that I'm going to put it in the description. Just watch that video so that you will find out how to find this beta naught, beta I, and this one. Okay, now we are particularly focusing on the error here. Okay, so now this is not observable in population. So now when we go for the sample here, see now sample regression function will have yi like this. Okay, now just note down here beta naught. I'm putting a cap here. That means we have calculated the value. See, for example, y is equal to beta naught plus beta 1 x1 plus beta 2 x2 will be the population one. Okay, so now by specific method, I found out the answer for this. For example, like this, y is equal to 0.25 plus beta naught value I found out already. It is 2.3 into x1, then plus 5.2 into x2. Just like that, I have calculated this. Okay, now this I'll call it as line of best fit. Okay, whenever I calculate the line of best fit, I am just noting this as beta naught on cap. That means we have calculated this value 2.52 like this. Okay, so now whenever we calculated this error function, this is also a random error. Here it is called residual. Okay, so this error is called residual. We are going to calculate for each and every x1 and x2, for example. Okay, now this is what we are concerning here. First of all, it is in sample regression function. We are going to calculate this error. So now in this video, we are going to see how it has been done here. So now before that, I just wanted to see what is that error. Okay, now so imagine this is a line of best fit. Okay, line of fit. See, for example, my values are lying on this. Okay, there is no residual at all. Okay, it is fitting correctly. Now when I have the line of best fit like this, my values comes here, one or two values. These values, how much is the distance from here? It is there. This is what I'm going to calculate it. Okay, so now these are all called the residuals here. Okay, these residual. See, from original value, how much it is deviating, that's what we are going to calculate. This is called the residual function. Okay, we have got so many names for this actually. It will be denoted by, see, for example, population, it will be denoted by epsilon, and sometimes it is denoted by mu also. Okay, so now for sample regression, it is denoted by E. Okay, so now EI means, what's the meaning of this? For the first equation Y1, E1 will be calculated. For Y2, E2 will be calculated. For Y3, E3 will be calculated. So suppose if I write this as E1, E2, E3, I'll call this as the error matrix or error vector. Okay, so now just visit the previous video so that you'll understand how it is being calculated. So now we just go on to this. Xi are the independent variables as usual, yi the dependent variable, and beta naught is the constant, bi are the regression coefficients. Now this random error in sample, okay, this random error in sample is called the residuals. Okay, so now we are going to see in this video how this is being calculated, then how it is being used to calculate SSE. Okay, so now that's what is the error we are going to see. Okay, so now we'll move on how to do it. Okay, so now we have given the same sum in the previous video. The link is in the description box. You can click and see. There is only one error you have to note. 0.1 the value has to be taken as 0. Okay, so now there is an error in the calculation. I have just put the error message there itself. So when I calculate that error, calculate without that error, I'll be getting a value here. I'm putting this particular equation here itself. Okay, right. So now residual, what is the meaning of residual? You should measure how far away a point is vertically from the regression line. This is the regression line, this is my point, vertical distance I'm finding out, how far it is there. I'm just wanting to find out, that's called a residual. Okay, so now what is this residual error then? Okay, so this residual error, I am just denoting it by E. So what is it actually? It's nothing but is the difference between the actual value of Y. So actual value of Y will be given already from that Y, and predicted value of Y. Predicted value, I will always write it as Y cap. So what is the difference between this? That is called the residual error. See, for example, the value of Y is 3, predicted value is 3.25. My error will be 0.25. This is often very necessary to find out how much it is deviated. So this is what we are going to see today, how to calculate the residual error. Okay, so now residual error is given like this, yi and y cap I. Okay, now this is the original value, this is the predicted value. The difference I am just denoting it for everything. Okay, now so we'll go for an example here. This has been taken from the previous video. So now calculate the residual. I have slightly modified that. Calculate the residuals for the following data set, given that the line of best fit is, the line of best fit I'm going to give this. Okay, this is what is the answer once the correction has been made in the previous video. If you are happen to go for that particular video, kindly change slightly the number, only one number. I have noted it down already. So we'll be getting this as an answer as the final one. Okay, now this is the beta naught, and this will be beta 1. X1 I'm going to substitute. This is the value of beta 2. This is what I'm going to find it out. Now, for this particular equation, how to calculate the residuals for the particular one. So we'll be having a value of Y, value of X1, and value of X2 to calculate this. Okay, so now what will be the data set? I'm going to give the data set. This is the value given already. Y is 3, 2, 4, 5, and 8. This is the value of the equation already fitted here. Okay, so now for this particular value, what is my predicted value? I'm going to calculate. That's called the residual error. Okay, so now I'm going to calculate how to do this. I'm going to show it. Okay, so first you write the value of Y here. Okay, the value of Y, it is already written. Okay, and the value of X here. This is the value of X1. I'm going to write the value of X1 here. Then value of X2, as usual, we have written. So now, what I am going to do here? See, for example, I'm going to calculate the predicted value here according to this given equation. This is the given equation here. Predicted value is denoted by Y naught. So for the X1 is 2 and X2 is 1. For the Y is 3, I'm going to calculate Y cap for here. Okay, so how to do this? I'm going to show it here. Just check. Now, this is the equation. Y is equal to 0.463. Since I'm going to calculate the predictor value, I'm denoting it by Y naught. That's the point number one you have to note. Now, what is my beta naught? Beta naught is 0.463. I have written here. Then what I'm going to do here, my beta 1 value is 1.02. That also I'm writing. So now here, what is my value of x1 here? X1 I'm substituting here. So that 2. I have given it as blue color so that you can see. So now 2 is the value of x1 I have written here. Now what will be the value of x2? It is 1. I'm going to write it here. Then I'm going to calculate this value. I'm going to show it in the end. So similarly, for the next equation, just you can imagine this x1, this is x2, and my y will be 2. That's what I'm going to write. For this y, I'm not touching this now. Right. Now, for the next one, this is the value. Okay, now x1 is 3, this is 5. I'm noting it down, 3 and 5. Finished. Next, 5 and 3, it's coming. So now 5 and 3 for that. Okay, now for the next one, it is 7 and 6, and for the next one, it is 8 and 7. Once everything is calculated, I'm going to calculate this particular value. What is it coming? What is it coming? What is it coming? This is nothing but the residual error. Okay. So with this residual error, what I'm going to do in the next slide, we are going to see. So now I'm going to calculate this value. I am posting it here. Okay, now 2.311 will come here. Okay, similarly for everything I have calculated. Okay, just you can do it manually also, no problem. You can use Excel also. You can use softwares also to calculate the residual error, but only thing you have to know how it is being calculated manually. Now I'm going to find out here this residual error here, y minus y cap. See, for example, say what is my already given value for y is 3 here. So now it is 3. My y cap is 2.311. Okay, now I'm going to minus it, 2.311. What is my value coming? I'm going to see now. So what is my value? For everything, y naught. See, this is the value I have posted here. Okay. Now, here I'm going to subtract this column. Okay. Now, this is subtracted with this one. Now, 2 minus this one will give you the next one. Then 4 and this. Okay. 4. So it will be negative always. 5 and 6. Now it is minus 1 and 8 and 7. So obviously you will be having the positive one. So this is how you will calculate the residuals for each and every value which is given here. Okay. So hope this helps you how to calculate the residual. So after calculating the residual, where can I use this? Okay. So we are going to just find it out. Two things here. Calculating sum squared error. Okay, that is what is called SSE from the residuals. How to calculate SSE from the residuals? This is the extra work I'm going to do it here. Now, SSE is called the sum of squared errors, also called as residual sum of squares. Now, RSS is nothing but SSE. You have to remember. It measures the total deviation of the response values from the fit to the response values. Okay, now line of best fit would have find out how much it is deviating. That's what I'm finding out from SSE. Now SSE is calculated how from the residual. That's what we are going to see. How to do it? So SSE formula I'm going to have is sigma I is equal to 1 to n yi minus y cap the whole square. What I'm going to do in the previous column we have calculated already yi minus yi cap. For each and every value, I'll square the value. Okay, then I'm going to add it. That is called a SSE. I'm going to show it in the previous one, you'll understand. See, now here we have calculated this here. Now in the next column, what I'm going to do is y minus y cap the whole square. I'll find it out for square it, square it, square it, square it, square it, and add it. That will give you SSE. Okay, so now this is just like similar example which is given in the matrix form. For example, suppose if I write E is equal to E1, see, for example, E1, E2, E3, for example, I'm writing E4 and E5 I'm finding out. Okay, so now I'm finding out the transpose of this and multiply with this. So transpose will give you E1, E2, E3, E4, E5. Okay, now when you multiply, E1 is multiplied with E1, then E2 is multiplied with E2. So this is what the squaring and adding. If you use matrix format, I'll write E transpose into E, or if I use a tabular column, I'll just write sigma y minus y cap the whole square. Both method works out. Okay, when I use a matrix format, I'll write E transpose into E here. Otherwise, I'm going to find it out. So there are two methods in calculating SSE. Now SSE is nothing but E transpose E when I use matrix format. Okay, now SSE is equal to now sigma y minus y cap the whole square for all the values. I is equal to 1 to n. Then I'll use the tabular column method or by hand. Okay, both method works out correctly. You will get the same answer for this. Now, how to calculate this, we'll see. Now, in our thing, see, in the matrix format, SSE is equal to E transpose into E. Now, when we just find out this particular column separately, that is my SSE. Okay, so no error for this. See, in our example, it comes around 4.39 for us. The SSE is 4.39 for us. It is coming. So this you can calculate and see. So we can have a data set. See, suppose if it is y is equal to beta naught plus beta 1 into x1 alone. X1 alone, you'll substitute and find it out. Suppose if it is beta naught plus beta 1 x1 plus beta 2 x2, the two values you are going to substitute. Okay, now once find out this SSE, there are other things you want to note it down. Okay, just note it down. This I just wanted to mention this. Actually, what will be the next thing we can calculate using this is mean squared error. MSE also we can calculate from this residual. So how to do this? Mean squared error tells you how close a regression line is to a set of points. I'm having a set of points here. This line, how close it is. I just wanted to find it out. Then I can use MSE. Okay, just like ANOVA, you can find out, right? So mean square error is also written as SE the whole square. In some other book, we can see SE the whole square. This is nothing but MSE. You can remember. Okay, in one book, one notation will be there. Right. Now, MSE, how it is being calculated? It is calculated. Just write your SSE here, divide by degrees of freedom of the particular thing. Okay, degrees of freedom, how I'm writing? So now this is nothing but SSE. We have calculated already and kept it here. Now my degrees of freedom will be n minus p minus 1. Now we'll see what is this n, what is this p, and what is this 1 here. Okay, now here n is the number of observations given in the model. And what will be p? P is the number of variables. Suppose in our case, x1 and x2, we have got it. X1, X2, the variables, they got it as 2. So this is how we'll calculate MSE. Now, you know how to calculate SSE as well as MSE. Don't confuse with this notations here, short forms. Sometimes it is confusing. If possible, we'll do a separate video. What are all the meaning of this? SSE, MSE, then SST will be there. All these things we'll do in a separate video if time permits. Okay, so what else I can do from this? Okay, I can find out one more thing from here. This calculating standard error of regression. This is just like a standard deviation. This is just like a standard deviation. How to calculate this? I will give this. Okay, standard error of regression is also called as root mean square error. So I'll call it as RMSE. What it will do, this measures how spread out the residuals are. Okay, my one value is here, one value is here, one value is here, how much spread it is there. Okay, now it is like this, how spread it is. I'm going to calculate using this RMSE. So what is the formula for that? It is nothing but the square root of MSE. Okay, the square root of MSE will give you the standard error of regression. Okay, this is also denoted by SE. I hope this makes clear how to calculate the standard error from the residuals. If I'm going to show it once again. So now these are the values. This value is a predicted value. So x1 and x2, I'm going to substitute in this particular given best line of fit. And then I'm going to calculate. Okay, this video has been done for one of our subscriber who was requested. So it is always a pleasure to make one video on request to satisfy our subscriber. If you just visit our channel, if you have any doubt or any videos to be done, we are very happy to help you out with a small video. Thank you very much. I just wanted to mention the particular person in the description box. Have a nice day. Thank you very much.